In this topic, we want to take the inverse trig functions, inverse sine, inverse cosine, or arc sine, arc cosine, arc tangent, however it is you refer to them, and we want to look at how we take the derivatives of those functions. So let's do just kind of a brief review of what an inverse trig function is. We haven't seen them yet in this class. You saw them in pre-calculus, but it probably has been a moment, so let's just do a quick little review here. The inverse trig functions, like any inverse function, what they do the opposite of the 6 trig functions. So for example, the square root of x is the inverse of x squared. They undo each other, so to speak. And so the same is true with things like arc sine as opposed to sine. Those are inverse functions. We talked about in the previous lesson how inverse functions, you have this swapping of the domain and the range, or the inputs and outputs. So whereas the trig functions, if you think about what they're looking like when they graph, or whenever we even say things like the sine of pi over 6, things like that, the input for a trig function is an angle, and the output is the triangular ratios So for example, when we say the sine of pi over 6 is equal to 1/2, that means that if I take pi over 6, that angle, run it through the sine function, which is opposite over hypotenuse, I get that 1/2. And that's what you look at when you look at those 6 trig functions. So whereas they input an angle and output the ratios, the inverse trig functions input the ratios and output an angle. So again, swapped, just like you do with any inverse functions for their inputs and outputs. So for example, the one we already kind of mentioned, the sine of pi over 6 is equal to 1/2. So if that's true, then that means that the inverse sine of 1/2, so 1/2 now, that triangular ratio is the input, that means that it equals pi over 6. That's the angle that gives me that particular ratio. Just going through some others here, so we could say since the tangent of pi over 4 is equal to 1, that means that inverse tangent of 1 is equal to pi over 4. And one other example, just to remind you, there are 2 notations for inverse trig functions. This is the first. That -1 is not an exponent. It is it's a notation saying that's inverse sine, inverse tangent. That is not sine of something raised to the -1 power. Sometimes to avoid that ambiguity, we say, so for example, the secant of pi over 3. And let's remind ourselves, secant is 1 over cosine. So if I want to evaluate that, I could look at 1 over cosine of pi over 3. Well, the cosine of pi over 3 is 1/2. And 1 over 1/2 is equal to 2. So the secant of pi over 3 is 2. Well, we have another notation for inverse sine, or inverse secant in this particular case. We can call it arc secant, and you'll see the little ARC go in front. And that kind of clears up some of the ambiguity between maybe what this -1 is representing. So we would say the arc secant of 2 is equal to pi over 3. So again, for these inverse trig functions, the input is the triangular ratio, the output is the angle, and in the next video we'll look at how do we find the derivatives of these inverse, we'll look at inverse sine, kind of get an idea for what that process looks like, and then we'll tackle the remainder of the inverse trig functions and their derivatives in the third video.